Hi, welcome to this video on Modbus TCP IP part 2. In this video, we will see the data frame, the Modbus data frame for Modbus query response cycles. And if you are not familiar with Modbus data frames or data types, I recommend you watch the first part of the video and continue with the part 2. And if you are interested in watching similar videos, please subscribe to the channel. Without further ado, I will begin the video. So this is the test setup that I have arranged for this video. I have two laptops which are configured as a Modbus client and a Modbus server. These are connected to the switch in order to form a local area network. So the client is based on the WinC software. The Modbus client is set up using the WinC software and the Modbus server is set up using the Modbus SIM32 software. Okay, now we will begin with the Modbus Coil query. So if your client wants to read the coil address 100, so what will be the data frame like? So starting from the right hand side, we have 4 bytes. The last 2 bytes represent the number of registers. So we are only reading a single register. This becomes 0 and 1. And these two represent the starting address. So the starting address is 099 because we are going to read from 99 plus 1. This becomes 099. The function code. The function code is 1 for Modbus coil. So this is 1. The unit ID, because there is only a single server available on the network, the unit ID becomes 1. And here you have the length. So the length is 2 bytes and represent the length of the remaining frame. So what is the length of the remaining frame? 4 plus 1 plus 1, 6. So this is 0 and 6. The protocol identifier is 2 bytes, and as mentioned in the previous video, this is reserved for future purpose. This becomes 0 and 0. The transaction identifier, again 2 bytes. This is already explained in the previous video. This increments from 0 to maximum and resets and so on. So all these values are represented in decimal. So in your protocol analyzer, you will only see hexadecimal format. So you need to convert this into hexadecimal format. So after converting this into hexadecimal format, this is what the application protocol data frame will be like. So what will be the response for the server to this query? So Modbus coil response. So this will be the response of the server to the query. So in the data frame, you can see here there are only 2 bytes. So what are these 2 bytes? The last byte represents the value of the register, and here it represents the remaining length of the data frame. So what is the length of the coil? It is single bit value. So there is only 1 byte here, and this becomes 1. Then we have the function code, which is also 1. Again, unit ID, which is also 1. Length 1 plus 1 plus 2, it is 4, represented in 2 bytes, so 0 and 4. The protocol identifier, as explained before, it is 0. The transaction identifier, it is again 0 for the first query. So this is the hexadecimal representation. Okay, now let us see the data frames in the Modbus simulators. So here I am using the WinC software to configure my laptop as the Modbus master or the Modbus client. So we will select the protocol, the Modbus TCP. Now I am in the WinC protocol analyzer. So using this software, I have configured my laptop as a Modbus client, and you can see this is the IP of my server. This is the port details. So let me ping. So I am connected to my server. The server is on a remote desktop connection, and it is configured using the ModSIM32 software. You can see I have different data types already available here. The device ID is 1. The coil status, holding register, input register, and the input status. All of these parameters are under auto simulation, so this keeps on changing at regular intervals. I will start the connection, and on the console you can see the traffic between the client and the server. So I will stop here. So the function code 1 is what we discussed, which is the Modbus coil query and response. So we will see this in detail first. So the query is here. This is my client sending the query. So here you have the raw data, the value, the number, the starting address, the function code. Here we have the raw data. This is the APDU. for the application protocol data unit. So this is in hexadecimal format. So the last 2 bytes represent the number of registers to be read. As I explained before, this is 0 and 1. These 2 bytes represent the starting address 0 and 63. So 63 in decimal is 99. So 0 and 99. This is the function code. So function code is 01. This is the unit ID. Unit ID is set as 1. This is the length of the remaining frame 0 and 6. This is the protocol identifier. Protocol identifier is 0 0, and here you have the transaction ID. Transaction ID is 0 and 1. Here you can see number 1. Okay, so this is the Modbus Coil query. Then we will see what the response from the server is. So the last byte you have the value. Here also just shown the value. The value is 0. Here you have the length of the remaining frame, which is 1. Here this is your function code, which is 1. This is the unit ID 0. This is the length of the remaining frame 0 and 04. So this is the remaining frame length. This is your protocol identifier. Protocol identifier is 0. This is the transaction ID 0 and 1. So this is the query and this is the response for the coil. Next we will see the query and response cycle for the input register. Now we will discuss about the Modbus input registry query. Say your client wants to read the input status of 30100. So this is your APDU. Starting from the right side, you have these 4 bytes. These last 2 bytes represent the number of register. These 2 bytes represent the starting address. You have the function code. Function code is 4 for the input register, and this is your unit ID. This is the length of the remaining frame. Protocol identifier is 0, transaction identifier is 0, and this is the hexadecimal equivalent of the APDU frame. And what will be the input register response be like? So this will be the server response. So here you have the data. So this is 16-bit register. So you have 2 byte representation of data here. This is the remaining length. Here you have the function code. This is your unit ID. This is the length of the remaining frame, which is 5. And here you have the protocol identifier, which is 0, and this is your transaction identifier. So let us go to the protocol analyzer to view the frames. So now I am in the protocol analyzer. So the function is 4 and this is the data frame. By analyzing the raw data, you can see these 2 bytes represent the number of registers. These 2 bytes represent the starting address. So 63 translates to 99 in decimal. So this is the function code. Function code is 4. 01 is the unit ID. 06 is the length. 00 is the protocol identifier, and 04 is the transaction ID. And what will be the response to this be like? So 4438, this is the hexadecimal value. So this is the actual value coming out of it. So this byte represents the number of bytes coming after this byte. So this is 2 bytes. This is the function code. This is the unit ID. This is the number of bytes coming after this byte. That is, this is the length 0 and 5. This is the protocol ID, and this is the transaction ID. So here we see the query and response for the input register. So next we will see the query and response of the holding register. Now we will discuss about the Modbus holding register query. So say your client wants to read the input status 40100. So coming to your APDU, on the right side you have the number of registers. These 2 bytes represent the number of registers. These 2 bytes represent the starting address. This is the function code 03. The holding register function code is 03. This is your unit ID. Unit ID is 1. Length is 6. 4 plus 1 plus 1. This is 6. 0 and 6. Protocol identifier 0. Transaction identifier 0. So this will be the hexadecimal equivalent for the query frame. So what will be the response frame be like? So the response frame, you can see here, this is 3 bytes Okay, so this will be the data. This is the data and this is the length. So this is 2 bytes, so here it becomes 2. Function code is 3. The function code is 3 for holding register. Unit ID is 1. The length is 5. 3 plus 1 plus 1 is 5. And then you have the protocol identifier 00, the transaction identifier 00. So what is the hexadecimal equivalent? Here is the hexadecimal equivalent. Now we are in the WinC protocol analyzer, and this is the query and response for the holding register. You can see the function code is 3. Okay, now coming back to the raw data, we have 0100, number of registers to be read 00063, which is the starting address, which translates to 99 decimal. 3 is the function code, 1 is the unit ID, 06 is the length, 00 protocol identifier, 0002 is the transaction ID. So what is the response to the query? So this is the value 41 FB. This is the value 41 FB. So 02 is the number of bytes coming after the byte here. So there are 2 bytes coming, 41 FB. So this is 2. This 03 is the function code, 01 is the unit ID, 05 is the number of bytes coming after the byte, 00 protocol identifier, and 02 is the transaction ID. So this is the same response that we anticipated from the lecture. This is the query and response cycle for the Modbus holding register. Next we will look at the query and response cycle for the input. Now we will look at the Modbus input status query. Okay, so say if your client wants to read the input status at 10100, and coming to your APDU, what will your frame be like? So here you have 4 bytes, and last 2 bytes represent the number of register. These 2 bytes represent the starting address. Function code is 2 for the input status, and your unit ID is 1, length is 06, the protocol identifier is 00, transaction ID is 00. So the hexadecimal equivalent is here, so 063001. So coming to the response, you have 2 bytes here. So this last byte represent the actual value. This value is the remaining length. So there is only 1 byte coming after this value. So here it becomes 1. The function code is 2 for the input status. Unit ID is 1. Length is 4. 2 plus 1 plus 1 is 4. And this is the protocol identifier, again 0, transaction identifier. So the hexadecimal equivalent is here. So we will go to our protocol analyzer WinC in order to view the data frame. Okay, now in WinC you can see the query and response cycle here for the input status. So input status, we can analyze the raw data. So 01 0001 is the number of registers to be read, 0063 is the starting address, so 63 is 99 in decimal, so 02 is the function code, 01 is the unit ID, 06 is the length, 00 is the protocol identifier, and 03 is the transaction ID. So what is the response be like? So the value is 0, so you have 00, this is the value, 01 is the length of the value, so 01 is the length, 02 is the function code, 01 is the unit ID, 04 is the length, and here you have the protocol identifier, and 03 is the transaction ID. Now we have completed the function codes from 1 to 4. So these are to read values of coil, input status, input register, and the holding register. So there are 2 other function codes, the function code number 5 and 6, which is to write to a single coil and a holding register. Now we are in the Modbus 4 single coil. So here the function code is 5. Say the client wants to write the value to the address 100. What will the APDU be like? So the last 4 bytes, these 2 bytes will represent the true or false. That is, if you want to turn the coil on, it will become 255, and if you want to turn the coil off, it will become 00. So here is the starting address as usual. So function code is 5, unit ID 1, length is 6, protocol identifier 00, transaction identifier 00, and your hexadecimal equivalent for the same. Okay, so now we will go to WinC in order to simulate the same and analyze the data packets. Now I'm in WinC, so on the console you can see all the traffic that was coming in before. I will clear this traffic. Okay, now I will establish the communication between the client and the server. So communication is established. So let me open the server. So this is the server. Okay, this is the server. So here you have the coil status. So the coil status at present is 1. So I will go ahead and change this. Okay, so I'm going to change this. Okay, now it becomes 0. So I will stop the connection and we can observe here. This is the function code. See, I'm sending this value to my server. Okay, so as I send 0, here you can see it is 0000. This is the value to be sent. This is the address 0063, which translates to 99 in decimal. So function code is 5, unit ID 1, 06 is the length, and 00 is the protocol identifier, 01B. This is the transaction ID. Okay, so I will establish the communication again, and I will turn this value to 1. Okay, let me select this one. Okay, now if I stop this here, and here you can see 0 0 and FF. So FF and 00 here I have turned on. So if I turn on, this value becomes FF00. If I turn off, this value becomes 0000. So now we have analyzed the write coil command. So write single coil. So next we have to look at the function code 6. So the function code 6 is to write to a holding register. So let us quickly go and see what the frame will be like. Okay, now for the Modbus preset single register. So say if you are going to write a value to the holding register 30100, which is the application protocol data unit. So here you have the value. These 2 bytes represent the value which you are going to write into your holding register, and these 2 bytes represent the starting address. And here you have the function code, which is 6 for writing to a holding register, unit ID 1, length is 6, protocol identifier 0, transaction identifier 0. So this is the hexadecimal equivalent. So the hexadecimal equivalent is here. These 2 bytes represent the value. So let us see in the protocol analyzer what will the frame be like. So now I'm in the WinC protocol analyzer. Let me clear all the traffic. Okay, so I will start the communication. So here you can see the holding register value. The holding register value is 14736. 14736. Okay, I am going to change the value. So selecting this, and I am going to write 10245. So if I write this value, you can see 10245 in the server. So let me stop here. Open the traffic. You can see the function code 6. Okay, the function code 6 is available here. So the data frame is here. So 2805 is the hexadecimal equivalent of 10245, and 063 is the starting address. Again, if you translate from hexadecimal to decimal, this becomes 99, and 06 is the function code, 01 is the unit ID, and the 06 is the length. Okay, this is your length, this is the protocol identifier, and the 016 is the transaction identifier. So this is the value you are writing, 2805. Okay, now we have analyzed all the data frames in Modbus TCP IP communications. Now we will discuss about Modbus exception. So what is Modbus exception? Say if the client requests the server to read the value of a particular register and there is no such a register in the server, then the server replies with an exception message. So what is the exception message? It will have the last will be the value 00, then you have the unit ID, you will have the length, so the length will be 3, protocol identifier, the transaction identifier. So in the case of Coil, the function code reply will be 129, and for the input status the function code will be 130, and for the holding register it will be 131, and for the input register it will be 132. So if the client is requesting for a address which is not available in the server, then the server will reply with the function code 129, 130, 131 and 132. So this is useful in cases where if you find these function codes, you can understand that the addresses are not matching between the Modbus query and the Modbus response. So far we have only discussed about the application layer, that is the application protocol data unit. We have discussed in detail for every function codes, that is function code 1 for coil, 2 for input status, 3 for holding register, 4 for input register, 5 is for writing to a single coil, and 6 is to write it to a holding register. Now we will see how the data packets are like when it goes to the transport layer, the network layer and the data link layer. In order to view the data packets, I am using the software tool called Wireshark. Okay, now I am in Wireshark, and here you can see this is the Ethernet network that I am using for communication between the Modbus server and the Modbus client. So selecting this, Wireshark will start to capture the packets. Okay, let me stop the packets here, and let us start analyzing from here. Okay, 172.168.10.3. so this is my client. 172.168.10.2, this is my server. So the protocol is TCP, and I'm sending an acknowledgement to the server in order to establish the TCP communication. Okay, so what is the message here? I'm sending, this is the source message, and going to the server. This is the client to the server. Protocol is Modbus TCP. Okay, length is 66. So what is the query? This is transaction ID 332, unit ID 1, function 4. So reading the input register. So what is the response? So the server 10.2 is replying to the client 10.3 Modbus TCP. So response is 332, unit is 1, function 4, read input register. So here you have the query, this is the response. So again you are establishing the communication TCP over here for the next query. So here this is the Modbus TCP. Here I am reading the coil status and I am getting the response status. And if you observe here, you can see this is your total frame. This is the total frame, the frame 2564 bytes. So this is the total frame over here, which is getting communicated through the network. And if you go here, this is Ethernet 2, this is the data link layer. Data link layer, you can see this is the address of the destination. So destination MAC address is here, and the source MAC address is here. Okay, this is my server MAC address, and this is the network layer. So on the network layer you can see this is IP4. Okay, this is IP4, and there are several parameters of the IP4 here. This is the source IP, this is the destination IP. The transmission control protocol, you can see source port is 502, destination port 57360. Okay, source port, destination port, and these are the TCP parameters such as window size and all. Okay, if you close this one, then when coming to Modbus TCP, you have transaction identifier, protocol identifier, length and unit identifier, and Modbus. So this is the function code. Function code is 1, byte count. Okay, so here you can see the complete frame, or the complete frame which is getting transmitted through the network for the Modbus TCP IP. So far we have discussed about various function, the application protocol data units for Modbus TCP, the packet capturing using Wireshark for Modbus TCP. So if you like this video, please leave a thumbs up and please subscribe to this channel, and I will see you in the next video.